Hello everyone. I think we can already start. So today we are going to talk about sets. It's another data structure which we have in C++. So let's start off with the question. And the question says, numbers are arriving one at a time. And after each time, we have to tell how many distinct values we have so far, like we have seen so far. As for example, we have some input like coming. Yep, we have some input like numbers arriving one at a time as 1, 2, 3, 1, 1, 3, 4, 5. And for even like for every single step, we have to answer like how many distinct numbers we already have. For example, we have 1, the answer is 1, right? We add 2, the answer is 2. We add 3, the answer is 3. And then we add 1, the answer is still 3 because we already have 1 before, right? So we somehow have to be able to answer this question every single time after adding a new element. And the question is, how can we do that? For example, if we didn't really have to answer every single time at every step, if we could, for example, insert every single, like input every single number and only after like answer the question, what would it be? We could input the whole array, right? And then sort it out and then just go through the whole thing and then like compare the neighbor elements, right? As we did like during the sorting class. And it would be like O n log n, right? Like the complexity, because sorting is n log n. So in this case, we have to somehow be able to answer this online as every single time as a new number comes, we have to answer it. Any ideas how can we do that?
Maybe like using, but it will be very, very complex, like unsquare, check every number of the inputs if it is equal to the previous number.
Yes, so the slow strategy would be every single time we add some element, we look back, right, and then we check with every single element before if it's equal or no. So if we don't really find any single element that is equal to the new one, it means that's a new element, right? So the number of distinct elements is like +1 after adding, right? Yes, but the problem is that we add n times and we check every single time n elements before. So it would be n square, right? So in this case, we have a better solution, and the better solution is with the new container that we are going to learn today, which is called set. So set is a data structure that we have in C++. We have to include a library called set to be able to use it. And the syntax for the set is similar to the vector, right? So set, the way that we declare set is set square brackets, and then inside we type the type. For example, int, and then the name s, which is the set s. And set represents a container which is always sorted and always unique. What does this mean? For example, the way we add elements to set is insert. So as insert, let's say 10, right? And let's insert another element as it's the same as, for example, like pushback, but the name is different, right? So pushback was for vector adding to the end. Insert is just generally adding element to the set. So insert 20 as insert 30, right? And then let's add another insert 10, for example, right? So, and also let's mix the order, right? So let's add like 30 first, 10, and then 10 and 20, right? So 30, 10, 10, 20, right? So for vector, it would be this in this order, right? But for set, it's a bit different. So let's try to output it. So I don't remember if we covered this or no. Does it make sense? This one? No. So in C++, so if you remember the structure of for, it's like for int e, right, equal to 0, e less than I don't know, n, and then e plus plus, right? This is the basic, like we initialize something, there's a condition, and then the change, right? So if we have, for example, a vector, vector int v, if we want to go through vector, the case for would be, for example, like e less than v size, e plus plus, right? But we can also do, for example, for int e double dot, I don't know, column, and v. So the way this works is that basically it automatically assigns, let's say x, it automatically assigns, like it goes through v and assigns every single time the v that would be here. It assigns to x. Meaning here x is equal to e, and e is just hidden, which means it automatically does the whole, like, you know, going through part, and then we have the final x already like assigned as v. So in case of set, it's not as it's a bit different, right? So with set, it's gonna be the first time that we encounter iterators. I'll talk about it in a bit, but let's say now x is just as here, like the elements of S set every single time. It just goes through elements. And auto, we could also write it like auto. Auto is just a command that automatically decides what type it should be. So here, if the vector is like int, or x is supposed to be int because we go through the elements and the elements are int, it automatically becomes int, right? So I'll talk about iterators in a bit, but let's say we output x, right? So can we try to guess what we will get?
10, 20, 30.
Yes. So let's try to run it. Yep. We get 10, 20, and 30, right? So in case of vector, we would get not ordered, not unique. But here we get set, right? So in the set, everything is unique and everything is sorted. 10, 20, 30, right? So in the initial question, right? this thing over here that's just n square wouldn't really work if n is big, right? But using set, what we do is basically the amount of distinct elements is the size of the set. Does it make sense? So if the set is all of the elements but unique, which means from every single element we only have one copy in the set. If we add many elements to the set, we are only going to have the not repeating distinct elements, right? So having said, let's write the program. So we have set s, right? And if we have like n elements input, every single time we input one element and then we insert the element into the set, by the end we are going to have, so we have to answer like every single time like how many distinct elements we have in the set at any step. So we do cout s dot size. Size just tells us how many elements we have in a set, right? So let's say let's run this. So we have like five elements. 10. We first add 10. We have one element, right? We add 20, 2 elements. We add 30, 3 elements. We add 10, 3 elements. We add 20, 3 elements still, right? And by the end, our set is just going to be 10, 20, 30. So this comes with an, let's say, exchange with the speed. Like as in the past, vector would be just O1 to add element, right? And O1 to access an element, right? But here, in this case, if we want to do as insert, it's going to cost O log n. So if we add, for example, n elements to the set, the whole adding process, like to the set, is going to be O n log n, because every single part is n is log n, and then we add it n times.
So can we first put all the elements in the vector and then insert the entire vector into the set to make it easier?
So if we put everything into the vector and then put everything into the set, it's still going to be n log n. Because set has some implementation underneath, like some structure, right? Some, I don't know, tree or something that we don't really know right now. And then that still has to be built, even if we have every single element. We still have to add everything one by one. So set has other operations too. Let's briefly cover the operations. So let's see. Set has the insert, right? So it's like add. It has, so not only we can insert elements, we can also erase, which means we can remove elements, right? And so how does it work is that s.erase some x is going to be remove x from set, basically. So if we have set of like 10, 20, 30, let's see, 10. So it's going to be, oh no, sorry. Let's see. So let's see, if you have like 5 elements. If you have like 5 elements, 10, 20, 30, 40, 50, right? So we have like 5 elements, and then we do erase 10, so you just remove 10, right, from the set. So insert was O log n, right? And erase is also O log n. Other than this, we also have size, which is just like the size, the amount of elements in the set. And this is O1, right, because we just have the size. We also have count. So in this case, it's gonna be the, if we have set, it's like, in set, if we want to consider like element x, it's either in the set or it's not in the set, right? So the count of the elements is either 0 or 1, right? So tells the amount of elements equal to x in the set, and it's O log n. Okay. We have empty, which is, we can remember from the vector, right? Empty is what?
Can I ask one question?
Yes, of course.
What is the difference between count and size? I think I kinda missed it.
So the difference between count and size. So size is just general size of the set. For example, if we have like, let's say the set is like 10, 20, 30, 40, 50, right? I mean, we can have this just a second. Let's remove this and this, right? Size and count. Let's see. So we see out size, and then we see out count, right? To just show how it is different. Let's move this so we can see every single element before, right? So here we have a set, we have 10, 20, 30, 40, 50, right? This is the set. And then size returns 5, which is the amount of elements in the set generally. So it's like 1, 2, 3, 4, 5 size. And then we receive 1, which is count of some specific element. As for example, in this case, 20.
Oh, yeah. Thank you so much.
Yeah, of course. So let's see what else we have. The empty, right? So as empty is just returning 1 if set has some element inside, and then it's it's returning 1 if the set is completely empty, right? So if it doesn't have any element inside, it just returns 1, and if it has elements inside, it just returns 0, the same as, for example, in vector. And then other than that, we have s.begin. This is just accessing the first element in the set. So if we have like 10, 20, 30, 40, just 10 points to 10, basically. And then we have the opposite, which is s dot rbegin, which is the right side beginning, which is this one, right? So also we have something called containers. No, we don't. Doesn't matter. Anyway, so we can have a question: why do we have begin and rbegin? It's a bit weird, right? Because, for example, in case of a vector, we've been accessing the elements inside with indexes, right? So the trade-off of set is that we can't have indexes. We can't access. We can't ask random elements. Which means, in case of vector, we could do like, we can access something like this, right? Oh yeah. So we could access elements with index, right? Like first element, fifth, sixth element, and so on, right? But in this case, we can't really have, like, for example, like fifth smallest. No. So what does this mean is that we can only access the beginning of the set and then the end. And which is basically like the begin, and then this is like the rbegin, right? Or if you want to access the end, which is just an empty element or something, like the end point, which is not even an element, it's called s dot end. And if you want to access, for example, like fifth element here, right? Let's say we have like 25, 35, 15. So 1, 2, 3, 4, 5. If you want to access this element, we can't do s something like this. No indexation. No. What we have to do is to basically start from the beginning. So here comes the iterator thing. Just a second. So let's say we have like auto e equal s begin. Okay, so if we have, for example, like e, it's an iterator, and then the way we move here from one to the other one, so we can access the fifth element, is that we have to do e plus plus, e plus plus, e plus plus, e plus plus. So we start from 0, 1, 2, 3, 4, right? And then we move pointer over here, and now it points here.
Can I directly write I plus 4 or I plus 4?
I don't think so. And if we want to move backwards, so to the right side is like plus plus, and then to the left side is a minus minus. Right. Okay, let's see. So if we can collect everything and then the answer like if we have to answer some question which is related to sorting, right, as we did like at the very beginning, if we can do it at the very end one time, instead of using set we should use vector and then sort at the end, right? Because if we do it, it's like still n log n, right? Both is n log n, both sorting and set if we do it like n times. But set is heavier. Even though both are n log n, set is heavier. The constant of the set is high. Like the complexity is n log n, but it works slower. So if you can avoid using sets, we don't really want to unnecessarily use sets, right? So the set earns its position to have only when we have to like answer or access data, ask queries and stuff, while data is being changed in the process. That's when we use set. So let's talk about multiset. It's a variation of set. I think we also have to add it here, right? Multisets, I believe. And multiset is different in a way of, okay, we don't have to add it. Sorry. So multiset is like included in set, right? So multiset is the same syntax, and we can access the same thing like as size, empty, insert, erase, what else? Count, right? Everything the same. The difference is that so if we add like for example 30, 10, 10, 20, it's not going to be 10, 20, 30. It's going to be, it's going to be 10, 10, 20, 30. So the difference is that it's called multiset. So we have still the sorted thing as in set, but we have multiple elements from the same number, which means it doesn't have the unique, it doesn't only store every single element once, it can store more. So if you have, for example, like leaderboard of like, I don't know, players, scores and stuff, and if they score the same, like 10 and 10, if we use set, it's going to erase one, which we don't want, right? We want to keep two. So multiset is when we want to just keep the sorted thing without having to like force the unique condition. So the difference also with set is the erase. So it's not a difference, but like so in this case, let's see, we have like 10, 20, right? 30, and then let's say 10, and again 10, right? So we have these elements in our set, right? So let's output them to see. Right. So we have these elements, right? 10, 10, 10, 20, 30, right? It's not like 10, 20, 30, it's 10, 10, 10, as we did. It's sorted, but it's not unique. So if we want to erase something, right? So in the past we said we would do erase 10, and then it would just erase 10, right? So what would happen if we do s.erase here? Yes, all 10s will disappear, right? So if we only want to erase, for example, one element from set, not all of the 10s, right? We have to do differently. So for that, what we can do is that we can use s.find. So what does s.find do? It finds a 10 in the set and then points to that 10. So if we do it like if we erase pointing to the iterator, which is like find 10, right? This is like a single point in the set, not just general number. It will kill only one element, while doing like just generally with the number, it will kill all of the elements. So we do find first, and then just erase it with the iterator pointing. And then in the case of count, it returns the general amount in the set. As for example, if we do count 10, we receive we receive 3, right? So the amount of 10s inside the multiset is 3, as we can see here. We also have to be careful. So it's not as, for example, if we want to erase something, we define like erase. If we just do it with number, as for example, erase 50. There is no 50, right? It won't really do anything. It will just do nothing. Like nothing is being erased because there is nothing to erase 50, right? But if we try to do it with find 50. Yes, s.find 50. So there is a problem because we can see there is an error, right? So if there is nothing in the set to be found, as for example, if we try to find 50, right? Find 50. So if we don't have 50 in our so if we don't have 50 in our set, it's going to point not to any element here, it's going to point to the s.end. And end is not an element, we can't erase end, right? So when we try to do s dot erase iterator inside, because it returns iterator, right? Fine. And if the iterator is s dot send, not send, end, we are going to receive an error because we can't erase n. Also, what time complexity of set so the time complexity for count in multiset is all log n k, where k is the number of occurrences of the element. Which means basically if we have like a set where we have like 10, 10, 10, 10, 10, so on, so on, so on, like let's say 100,000 of 10s inside, and then 5 20s, 5 30s, right? Let's say if we do like count 10, it's not going to be all log n, which is like around 20 or something. Not 20, like 7. It's going to be these plus 100,000 of 10 killing. I believe the way it works is it just finds the 10 beginning, right, or something, which is like log, which is like log n, the first finding part, and after that it just goes one by one, plus 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 until it's still 10, and it just counts by heart like how many 10s we have. Because like why couldn't it do like, you know, just find the first, find the last, and then just deduct from like the end to the beginning, like index wise? It can't, because there are no indexes. It's not like one like in order. The way set works is it stores everything in a smart way to be able to answer to the queries that we are able to answer with set. But the downfall is that we don't have indexation, right? So it's not in order, so it can't really do like one and do that. So it has to go like one by one by one by one by one, and that's why it's plus k. The same for erase. As for example, if we want to do erase 10, if we have k elements like equal to 10 in the set, it's going to cost us all n log n, all like log n plus k, not just log n, because we have to erase one by one by one by one by one, or something. Or no, it's not like multiplication, just k. Anyways. This is the complexity. So let's see. Just a second. So about the iterators. So I would recommend to just use auto. What's wrong? Yeah. And for example, we declare iterator and then we set it to the rbegin, right? So in this case, this would be our point, like iterator, as we point to the element with the iterator. But then if we try to do like a cout e, we can't really do that, right? Because it's an iterator. It doesn't represent the value, it represents the link to the element. And if you want to return, if you want to like output the value behind the behind the box, like the data, we have to use this thing over here. So in this way we just access the value inside, right? Let's see. What's wrong? Yeah. So here we can see 10, right? The same, for example, if you want to do like rbegin, right? We can't do that again because it's an iterator. It's not the value by itself. So for that we have to do again with this symbol. It just accesses the value of the iterator. And if you want to move forward, if you want to go through the whole set with the iterator, the way we do it without auto, because auto is just this, right? If you do auto x, it's going to automatically assign the value. So instead of doing auto, we can do, for example, iterator e equal to rbegin, right? This is like the initializing part, and then for the condition we are going to check if e is not equal to the end, which is the end of the set, right? And then every single part we are going to do is e plus plus, which is just one move from the position to the right. And then every single time let's output the symbol e, which is the values of the set. So here we can see 10, 10, 10, 10, right? So it goes like here, output this, output this, output this, output this, output this. And then after it does e plus plus, it becomes s dot end. Here we can see. And then after it just, the condition doesn't satisfy and just breaks from there. before. Right.
This is a set, but why does it have duplicate numbers?
Yes, so this is multiset, right?
Or multiple?
Yes, it's not set. So if it was set, right, it wouldn't really have any duplicate numbers, as we can see here. Yep. So, and for example, if you want to do like second element, so without like initializing like something e plus plus, blah, 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 if you want to do like the second smallest element, right? The way we can do that is just cout symbol, right? Begin. But this is like, it points to the first element, so we do plus plus. And then we can see here, it's 10. Why? Because we have to do brackets. So we move first, and then after we access. Right? No? Just a second. I'm confused. Oh yeah, okay, never mind. Yeah, so the difference, so we didn't really cover this. So what's the difference between this and this? Plus plus S and S plus plus. So let's look into it like from the perspective of just numbers, not sets. Let's see if we just have like int x equal to 10. So if we do like x plus plus, what it's going to
11.
let's see. It's 10. But then if we just see how it takes again, without anything, like without changing anything, it's going to be 11. The way it works is that if we put plus plus at the end of the operation, it's going to execute the operation and only then change the number, right? So here it's just like it outputs the first like number, and after that only changes the number. The same in case of the. So if we do it like another way, if we do like not x plus plus but plus plus x, it's again going to do like plus 1, right? But it's going to do it first and only then move to the second. So same for the set. Basically here the plus plus and plus plus works the same way. If we do it like after, it's going to see out the first element and then move to the second one. While if we do plus plus and then s dot begin, it's going to move to the second one and only then see out, as we can see here. And if we do it like plus 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 plus, like 4 pluses, it's going to do 1 plus, like it's going to do 1 plus and then the second plus, which is like from the first one to the second one, and for the second one to the third one. We are going to get 13. And if we do one more, which is going to be so in our set we have like 10, 20, 30, right? So initially it's like on beginning it's like this one, and then we do plus plus going to this one, and then we do plus plus going to this one, and then we do plus plus going to Sn. So here what we will get if we do this,
Error.
we will get error, right? because nth doesn't have a value. Interesting. Fair enough. Let's see if it's the same. Oops. Fair enough. Now we are getting the size. I'm not sure how we're supposed. Anyways, I guess we're just getting the size with the end. Okay, I didn't remember that. But yeah, be careful with end. End can cause a lot of errors, so we have to always check a lot of stuff. Okay, let's talk about next possibilities that we get with set. So it's going to be the lower bound and upper bound. If we remember from sort, do we remember?
Probably.
Like we had something called lower bound and upper bound, right? I'm not sure if we call it, but anyways. So vector. Just a second, sorry. Oh my goodness. Sorry, just a second. So, let's see. If we do like push back, one, doesn't matter. And then basically, we don't really have to do it right now. But anyways, so we had the lower bound, right? Did you call this? So the way it worked is like we begin, we end, and then some element x. Basically, let's illustrate it as we have. So for lower bound, the array or vector had to be sorted, right? For example, like 2, 3, 4, 5, right? Or maybe 3, 5. Let's do like this, 7, 9. So if we have like this self lower bound, we can do that because it's again like iterative. We have to do minus the beginning. So it's like the basically the distance, like 1, 2, 1, 3, 5, 7, 9. If we have like lower bound pointing to this, and we do like minus v something something at the beginning, right? In this case, we are going to receive the index. So let's illustrate it. We have like 1, 3, 5, 7, 9. Let's put the index. Not the index. Let's put the x value that we're going to lower bound. Lower bound is the we didn't call it values. It was in advance, I believe. Yeah, it was in advance. Sorry. Um, okay, let's just understand how, not how it works, but what it does. It just, with log n, all log n complexity, it points to the, if we have lower bound, it points to the first element, first index, that is, if we do lower bound x, it points to the first element that is more or equal to x. As for example, in this case, let's say we have 4. No, sorry, wait. No, not more than equal.
Still didn't understand what bound.
Okay, let me just do easier way. Upper bound C++. So lower bound is the first occurrence of target element. If element not found, index of the first element greater than target is returned. So if we have like 5, if we do lower bound 5, here it's going to return like the element 5. Otherwise, it's going to get and return the first element greater than 5. So the element which is more or equal its first element.
So like if input is 4, it will give us 5.
Yes. So here in this case, this is the index. That's why I was confused. It's not the element, it's the index. So we get 0, 1, 2, 5. And then the upper bound is not greater or equal, it's just greater than x. First element is greater than x. So if we give 5, it's going to give 7, not 5. Right? So this is about lower bound and upper bound. And then for this to work, we had to have the condition of vector or array being sorted. It has to be sorted. It has to be sorted to work. So if you want, you can go to the advanced division recording of the class about binary search. There we are covering the binary search algorithm with explanation. And with that, you'll understand how the lower bound and upper bound works. So in case of sets, we have the ability to access lower bound and upper bound already implemented into the set. So we don't do like lower bound. Like if we do lower bound begin, lower bound s and x. Interestingly enough, it's going to work, right? So what is the difference between these and also this? The difference is that this is implemented into the set and it works in all log n. But this one, but this one is just general lower bound. It doesn't really use the ability of the set, and because of that, it just does the basic lower bound with the set. And every single access to the set is log n. That's where we get, instead of log n, we get log square, log n square, log n times log n. So be careful, because in the past, when I was just at the very beginning, I got problems using this one because I didn't know that it's like slower than this. So instead we just use the built-in operation instead of this because this is like slow. So we can access the lower bound and upper bound as, for example, like as lower bound, let's say 15. So here again, it's an iterator. It returns an iterator. So if we want to output the actual value, we have to do this. So let's see, and we will receive 20. If you have 10, 20, it's going to be the first. So if we put 15, the first element that is more than equal, more or equal to 15, which is 20. We have 10, 20. Let's add another one so we don't have the small sense. And we can also access with the same logic s dot upper bound, which is just the same without equal case. So if we do like 20, we will receive we will receive 30, right? Because upper bound 20 we have 10, 20, 30, 40. This is equal, but we don't really care. We have to look for greater than 20. And then, for example, if we do like upper bound 40, we will receive the end. So we have to check if let's say auto iterator equal to as lower bound 40. So we have to check if if iterator is equal to as end. For example, we say none, because if there is nothing, if there is no element greater and equal to 40, okay, no, of upper bound, sorry. If there is no element greater than 40, it's just we have to return, for example, none, right? Otherwise, we return the element by itself, right? So in this case, 40 is the largest element. There's nothing greater than 40, so it's none. For example, if we put like 100 or 1000, again, none, right? And if we did, for example, 20, we will just receive. Yes. Just a second. So for example, usage for upper bound and like lower bound and stuff. Let's say we have to have a structure that will support. Let's say we have tickets. Set of tickets. Every single ticket is like it costs something. Let's say like ticket that costs like 10, 20, 30. The VIP is like 1,000. 15 minutes. So, and we also have like several of those tickets, right? Because it's like a big stadium, right? We have like people coming, and every single person has some amount of X money, and they want to buy the best ticket that is affordable with their money. And is like available, right? So let's say we have like let's say we have n people coming and n tickets, right? And then for every single ticket we have the price, right? We have m tickets, and for every single ticket we have the price. We are going to store it in multiset. And we have to insert those, right? And then for every single person, so people come and they have some amount of X money, right? So for them we have to answer the best ticket, make the best ticket's price, which is under their available like money, right? Like they have some X amount of money. We have to answer the best ticket that they can buy, like the cost of the best ticket that they can buy, and the ticket is still available because if we have like, for example, two $20 tickets. If we sell every single ticket, there are no $20 available, right? So the way we do it, we get the price, we get the money, right? And then we have to get the highest available ticket, which is lower or equal to money, right? So how can we do that? We can do, so if you remember the lower bound is like the first element that is like greater or equal than money, right? If we do upper bound, is the first one that is like greater than money, right? So if we want this, we can just ask for the upper bound, the first one that is greater than money, and just do minus, move back, and we'll get element which is lower or equal to money, right? So let's say auto x equal to s dot upper bound x, and here we have to check. We have to check what? We have to check if the iterator is not equal to s dot beginning. Why beginning? Because let's say we have like elements here, right? So if we get, for example, the last one, not the end, like the last one, right? In that case, we can move back, right, to this one, right? If we receive end, which is like not even an element, so there is no one, there's not any element that is like greater than money, right? In that case, even though it's at the end, we can still do minus and move to normal element, right? And receive the lower money, the element that is lower than money. But only if we have element pointing into the beginning. In that case, means that the smallest element is greater than money.
Too poor cannot buy
Yeah,
tickets.
that means too poor cannot buy any tickets. And we have to check that, right? Because if we do like beginning minus, we're going to receive an error. We can't go further left. So if it's, let's say if it's equal to beginning, that means like we have to tell that there are no tickets available, right? No tickets today. And then otherwise, we told them like the the price is going to be iterator with the symbol minus, right? Because we go left and we give the command. So let's see. Let's say we have like 5 tickets, right? No, we forgot something. What did we forget? We forgot to erase, right? Because after getting the ticket, we have to, let's say, make it unavailable, right? So after this, so this one is already pointing to the correct element, and we do s.erase iterator, right? So let's see. Let's say we have like, oops. We have like how many? 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, let's say 11 tickets. But first we have to put like the amount of people. Let's say we have like 20 people, 11 tickets. And then we have to insert the tickets, right? And it doesn't really have to be in order. We can have like not ordered, but this will be like ordered in a set, right? So 10, 10, 10, 10, 10, 20, 20, 6 already, and then 30, 30, 50, 1,000, right? 2, 1, 2, 1, 3, 1, 2. And here we're going to put the people one by one. So let's say we have 10. We sold 1 ticket, right? We sell another ticket. We sell another ticket. We sell another ticket. And then we run out of 10s, right? So if we do again, no tickets today, sorry, right? If you do 15, no tickets today. If we do, let's say 950, right? 10,000, 1,000, 10,000, 1,000, 10,000, 30, 100, 30, 100, 30, 20, 100, 20, 100, 20. We run out of tickets. No tickets today, sorry. Right? Okay. Let's also talk about, let's see. So the complexity of lower bound and upper bound here are all log n, right? Only if we use like the s dot lower or upper, not the regular one. And the next one that we're going to discuss is going to be something called unordered set. So unordered set is a bit different. The structure of unordered set is different. The things that unordered set can do is also different. Let's. So. Just a second. Yeah. So it says there is a third flavor. An unordered set. We have to include it like separately. It's different than set. So include unordered, not map set. Right? So it answers have I seen it in O1 on average. It's not like fixed O1, it's average amortized. Instead of log n, but it gives up all ordering. No sorted iterations, no lower bound, no smallest element tree. So in this case, we are going to have a structure which is going to handle like it's just going to be a set without order, so no sorting, no like this, no indexes, nothing, and no uniqueness. It's not like set. It doesn't like make it unique. No, it doesn't sort it out. So we can't really have like lowest element or anything. We can't use lower bound. We can't use anything. The only thing that we can use is, for example, let's see what we can use. As for example, count, right? It's fast. It's all one. So, for example, if we have like unordered set instead of like set or multiset, unordered set. So, as we can see, it gives like error when we try to do upper bound, right? Because it doesn't support upper bound. So let's do insert 30, insert 20, insert 10, and then copy the same thing here again. Like let's insert 20, 30, 30, 20, 10 again. So 30, 20, 10, 30, 20, 10, right? So let's go through the set for auto it as out. Oops, forgot to remove this. Okay. Sorry, I gave misinformation. So, yes. It wouldn't make sense if it didn't have. Okay, so another set actually it doesn't have duplicate. It's unique. It's just not ordered. So it does what set does, but without order and with O1 average. So no sorted iterations, no lower bound, no smallest one, blah, blah, blah. So if all we need is just membership, unordered set is faster. And the moment we need sorted order, smallest, largest, or lower bound, we have to have real set. So let's think about what example I can bring for unordered set. Let's say we have to answer the appeared not appeared thing, right? So like the amount of duplicates, right? In that case, if we use unordered set, it's even faster. Like we, instead of doing like n log n with set, like every single time adding to the set the element and then answering, like outputting the size, right? That represents the duplicate number. duplicate number, sorry, the amount of distinct elements. The first question that we had. Right. If we can use another set, and it's going to be faster. Every single operation is going to be O1, which means it will be ON instead of O n log n. So let's see. A quick checklist before we call it done. So as we said, set doesn't have indexes, no random access. If we need to have multiple elements, we have to use multiset. Don't forget that set silently drops duplicates. So if we use erase on multiset, it removes all of the copies. And if we want to exactly like just remove one element, we have to do erase with find. So find the iterator and then erase with the iterator. Using the free, which is like the global lower bound, instead of the implemented like inside lower s dot lower bound. It's correct, but it's slow. It says on. I'm not sure about that. It might be on. It might be o n square, log n square, but doesn't matter. It's slower. Reaching for another set. Basically, another set doesn't have lower bound. It's not sorted, so we can only have like the duplicate thing with another set. It's faster, but it has limitations. And using set where a vector plus one sort would be simpler and faster. Basically, if we can use just vector with sort at the end, for example, we don't really have to use set because set is heavier. It's a very heavy structure. And what would and in case of like, for example, both being as like n log n, one case might be way slower than the other case. So there are some practice questions. As just like to write code and try. And also like problems with the judge. Please take a look at home. Try to practice. And also this is the like the Google sheet where we have the let's say problems for every single topic. I'll add also the set over here with like according like I don't know 10 problems or something, so you can practice more. And I'll add the PDF and stuff. Yeah. Thank you for the class. Thank you for attending. I think this is for today.
Thank you.
And see you, I guess, the day after tomorrow. Yeah. Thank you. Bye-bye.